What do you know about the adrenal glands and the pancreas? Huh? You're about to know a whole lot more. Here we go. All right, the next phase of our endocrine chapter is all about the adrenal glands and the pancreas. So with our adrenal glands, we're looking at the kidneys, but really what's sitting on top of the kidneys, because that's where we find our adrenal glands. So I drew a little kidney here, don't judge me. That's my adrenal gland on top of it. So it sits on top of the kidneys, almost like a little hat. And we've got two very distinct areas to our adrenal glands, my adrenal cortex and my adrenal medulla. So when it comes to the cortex, first of all, let's remember cort. That's going to make our lives a little bit easier later on. Cortex, cort, that will come into play. So two areas, adrenal cortex and adrenal medulla. So if we look at my cross section, I pulled my adrenal gland off the top of my kidney and I cut it in half so we can look at the middle of it. Around the edge, I've got this lighter blue area. This is all my cortex. In the middle, I've got this darker blue area. This is my adrenal medulla. So remember in Latin, medulla means middle. So it's literally the middle of my adrenal gland. The adrenal medulla, the middle of my adrenal gland is all we're talking about. But this is important because we're going to treat our adrenal cortex and our adrenal medulla like two different hormones or two different endocrine glands completely, because they secrete different hormones. So a lot like we did with our pituitary gland, we had an anterior and posterior that we treated separately. We're doing the same thing here with our adrenal gland. So I've got my adrenal cortex and I got my adrenal medulla. So let's look at the adrenal medulla first. So we're in the middle part here. The hormones it releases are epinephrine, aka adrenaline, and norepinephrine, aka noradrenaline. Epi and norepi. So both of these hormones have the same effects, very similar to that of the sympathetic nervous system. So remember, our sympathetic nervous system is fight or flight. So it's everything we've got to do to either fight for our lives or run for our lives. So it's going to speed up our heart rate. It's going to increase our blood pressure. It's going to increase our respiration. And all of those vital functions go up with the sympathetic nervous system. My hormonal effects from my adrenal medulla with epi and norepi do the exact same thing, but the hormonal effects last 10 times longer than that of my sympathetic nervous system. Also, we need to be able to distinguish between these two because they both do the same thing, and we do that because epinephrine also will increase blood sugar levels. So I'm going to put increase blood sugar. We're going to increase blood sugar levels with epinephrine. Norepinephrine has little to no effect on blood sugar whatsoever. So that's how we will make the distinction between those two specific hormones. So my adrenal medulla, the first part of my adrenal gland, two hormones, epi, norepi, adrenaline, noradrenaline. They both do the same thing, except for epinephrine also plays a role with blood sugar. The second part of my adrenal gland is the adrenal cortex. So my adrenal cortex secretes a bunch of different hormones, 30 different steroids alone. We're going to talk about the two most important ones, in my opinion. I've got aldosterone and I've got cortisol. Aldosterone and cortisol. So we'll look at aldosterone first. Aldosterone, aka mineral corticoid. So there's that cort coming back into play. The aka for aldosterone, mineral corticoid, because this is my cortex. It helps regulate blood pressure by managing the amounts of sodium, salt, of course, and potassium in your blood. The salt and potassium absolutely will have an impact on your blood pressure. We want to be in control of that impact, so we use aldosterone as the hormone that helps us do that. It also manages the mineral electrolytes in our body, which is how we get the name mineral corticoid, because it's all about those mineral electrolytes. So my first hormone for my adrenal cortex, aldosterone, aka mineral cortex corticoid, mineral corticoid. The second hormone I get from my adrenal cortex is cortisol. So now we're back to that cortex, cortisol. That's probably the best one to remember. Cortex, cortisol. I'll put that in your brain so it sticks there forever, aka hydrocortisone. We've all heard of hydrocortisone, but there's that cord again coming into play. It's all about that cortex, the adrenal cortex. This is called the stress hormone. The stress hormone, because it helps regulate your body's response to stress. How do you respond to stress? It's going to come down to what your cortisol is doing in your body. It's also going to help regulate the use of fats, proteins, and carbs on your metabolism. It's going to help suppress inflammation, which is huge. And it helps keep blood sugar levels within that normal range in between meals. So we're not constantly having to eat to keep those blood sugar levels where we want them to be. So we have energy all day. Cortisol plays a role into that. Now, there is a pathology associated with cortisol, and that is Cushing's syndrome. Cushing's syndrome, a pretty easy one to diagnose, but it occurs if you have too much cortisol over long periods of time. So your adrenal cortex secreting too much cortisol is running rampant in our body. Cushing's syndrome is the result of that. So some of the symptoms we look for: a rounded hump between the shoulders. Now that one's a little bit more trickier, but the easiest one I think is the rounded face. That's something you're going to notice right away when a patient walks in. If they've got that rounded face, that kind of puffy appearance associated with it, then that's going to at least point us in the direction of Cushing's syndrome, and we can run some labs on that to find out. The other easy one or the easier one, I should say, are pink and purple stretch marks, especially on the torso region, abdomen and torso region. These pink and purple stretch marks, really, really obvious when you see the patient, that they have to take the shirt off for that, which is not something you're always going to do with that initial visit. So that rounded face really is what comes into play. So enough about the adrenal glands. Let's shift gears now and look at the pancreas. So the pancreas is unique because it is both an endocrine gland and an exocrine gland. So that is something that makes it distinct. We will also be coming back to the pancreas to talk more about it when we get to the digestive system. But just so we know, 99% of your pancreas is dedicated towards your digestive system. Only 1% is actually part of the endocrine system, and that 1% is what we need to look at real quick now. So with our pancreas, we will notice we've got cells grouped around blood vessels. We call these cells pancreatic islets, or more commonly, at least in my experience, the islets of Langerhans. The islets of Langerhans is just what we call the cells that are grouped around the blood vessels inside of our pancreas. Now, if we take a closer look, what we're going to see is we've got 3 different types of cells, and they are each secreting a different hormone. So 3 different types of cells secreting 3 different hormones. And this is pretty easy. Alpha cells, beta cells, delta cells. My alpha cells are secreting glucagon. My beta cells secrete insulin, and my delta cells secrete somatostatin. Alpha cells, glucagon; beta cells, insulin; delta cells, somatostatin. So if we look at the pancreas a little closer, before we get into it, though, I want to make sure we're clear on some terminology so you don't get confused, because some of these words do sound very, very similar. And we've talked about some of them in Anatomy 1, and we're adding to it now in Anatomy 2. So glucose, of course, is a sugar molecule. One sugar molecule is a glucose molecule, and it falls into the category of a carbohydrate. That's how we know sugar. Carbs are my sugars. Then I've got glycogen. This is just several glucose molecules that get bonded together, and then we store that in skeletal muscle until we need it. And then we can pull it back out of the muscle, break it back down into the glucose, and use it to make the energy that we need. But until then, help get it out of our bloodstream, we can store it in the muscle. And we do that with glycogen. Glycogen is the polysaccharide that we make in our bodies, not to be confused with glucagon. So glucagon, this is the hormone released from the pancreas that is going to increase your blood sugar levels. Pancreatic hormone that's going to increase your blood sugar levels. Opposite of insulin. Glucagon is the opposite of insulin. Insulin, pancreatic hormone, that's going to decrease your blood sugar levels. And then our third and final hormone is somatostatin. This is our pancreatic hormone that helps regulate our carbohydrates, regulate those sugars so we know what to do with glucagon and insulin. So we have three hormones that we care about with our pancreas: glucagon, insulin, and somatostatin. Now do your best to not confuse glycogen and glucagon. Try not to get those mixed up. Make sure you got an understanding of each of those to make your life just easier. So now that we got our terminology down and we know what these hormones do, we need to look at a little bit of pathology that gets associated with our pancreas, and that is diabetes. Diabetes, of course, comes in two types. I've got type 1 diabetes or type 2 diabetes. Type 1, this is when your body doesn't produce insulin. And if your body's not producing insulin, then we are not able to remove that sugar out of our bloodstream. So we end up with just high blood sugar constantly, and that's going to have damaging effects all across our bodies. So insulin injections are required for someone with type 1 diabetes to move that sugar out of the blood. And typically this gets diagnosed before the person turns 40. We're going to figure out, hey, we've got something going on. Type 2 diabetes, this is when your body isn't making enough insulin, or the insulin that it is making is just doing a crappy job at removing the blood sugar. So we end up with, high blood sugar again. This one we typically try to control first with diet, exercise, see if we can't make some lifestyle changes for those corrections. But medications are also there if we need them. And that's the pancreas. Pretty straightforward. Make sure you understand the difference between glucagon and insulin. Don't get those confused. Remember, we say outsulin because that's what we're doing. We're taking sugar out of the blood with insulin. Don't get that. I don't know what I just did with my arm, but you get the idea. Good luck.